Good day everyone! So for today's video, we will going to prove one of the theorem of subgroup test in abstract algebra, which is the one-step subgroup test. But before we proceed, let me introduce myself first. I am Ken Otero from Bachelor of Secondary Education, major in Mathematics 3A. So let's proceed. By its definition, let G be a group and H a non-empty subset of J. Now, if A, B inverse is in H for any A and B is an element of J, then H is a subgroup of J. Okay. Now, how to prove this? So, in order to prove this, we are going to say that if AB inverse is in H for any A and B is an element of H, then H is a subgroup of J. So first, we have to show that H is not equal to empty set. Typically, we show that E is an element of H. So number 2, let A and B is an element of H and show that AB inverse is an element also of H. So essentially, we are going to let this be true. So we are going to let A and B both be element of H, which is the subgroup. So we have to show that what is then true is that A and B inverse is also an H. So proof using one-step subgroup test. So by its definition, let G be an abelian group with identity E. So with identity E. So prove that H is equal to X element of J such that X squared is equal to E is a group of J. Now remember, abelian tells us that AB is equal to BA for all A and B, E, G. So essentially, we are saying that is commutative group with identity E. So prove that H, which is the subgroup defined as all x's in G such that x squared is equal to the identity or essentially all elements of order 2, where I perform the operation twice to get back to the identity, is a subgroup of J. So, how am I going to show that H is non-empty set? Well, first, E is an element of J. So, remember that E is an identity, right? So, and E squared is equal to E is an element of H, whereas the definition of H. So, therefore, H is not equal to empty set. Okay. So my second test is closure. So closure says that AB are going to be an H, and I have to show that AB inverse is an element also of H. Now, so if A and B are elements of H, then I can say that A squared is equal to E, and B squared is equal to E. Again, based on the definition of the subgroup or subset. So both of those are true. Now, what I'm trying to show that AB is an inverse of H. So, since J is abelian, then AB inverse to the power of 2 is equal to AB inverse times AB inverse because it's abelian. So, B inverse A is the same as AB inverse. So, I'm just basically switching the order. So, AB inverse, that gives me A squared. B to the power negative 2 is equal to A squared times B squared inversed. Well, A squared, as we know, is from identity E, and B squared is an identity of E inverse. So the inverse of identity is the identity. So essentially, it's give me the identity. Therefore, I have just proved that AB inverse is an element of H. By the one-step subgroup test, is I can say that H is a subgroup of J.